Okay, so here's skill 0. So what we're trying to do is find the equation of the perpendicular bisector of the diagonal. So right here I drew my rectangle, and here are the 4 points of 5, 6, 5, 0, 13, 6, 13, 0. And coincidentally, this is a length of 6 and this is a length of 8. And by doing Pythag, we know that this total diagonal is going to be equal to 10. And this diagonal, since it can be perfectly cut in half, we know that this half of it is going to be 5 and this half of it's going to be 5. So basically what I did is I took this portion right here and I drew it down here. And since this has to equal to 5, I know that a 3, 4, 5 triangle, I know that it has to have the sides of 3 and 4. So I just found the point that is 3 away from 5, 6, which is 5, 3, and 4 away from 5, 3, which is 9, 3. And from there, what I did is I took my slope-intercept formula and I plugged in the y and x coordinates of this pair right here. So y minus y1, which is 3, is equal to the slope, which is 3/4, because we went down 3 over 4. And that should actually be negative now that I think of it. And so then times x minus 9, which is the x coordinate, and then I solved it out, and what I got was y equals negative 3/4 x minus 3.75, which is the equation of this line right here. And then just another skill 0 that I did, which you don't have to keep watching, but you can just see how I figured this out. And so right here, the problem I did was the difference of two real numbers, a and b, is the square root of 2, and their quotient is 6/5. So solve for a or b. So basically this is really easy, and so we just know that a minus b is equal to square root of 2 because it says the difference of them is square root of 2, and we know their quotient, which means dividing, is 6/5. So right here we know that a is equal to 1.2 b because I multiply each side by b, and right here I got a is equal to b plus square root of 2 because I added b to both sides. And then basically I made them equal each other and I solved it out, and just a bunch of math stuff, and I got this as the final answer.